In the previous video, we saw how JUnit or the JUnit framework was set up, and we took the simple example. Actually, didn't really run this today, so let's take a look at this simple example. Just a simple main method that creates a simple computations object. This is fairly simple. It's just got two private float data members, constructor, and then a couple of computations, just subtraction and division. Actually, just very simple. And then what we're going to do is, just to figure out how JUnit works, we're going to write some simple tests. And to do that, we use the JUnit wizard to generate this simple class, which has basically a test for each method in the class that we're testing. And then it also has a setup before class, teardown after class, a setup class, and then a teardown. Okay, so, and also we saw that when you run it, by default, the wizard sets up all of these tests to fail, which is what you want. They should fail at first until we implement these tests, and then after that they'll start passing. So the first thing you want to do is to modify this test class, and we have to put in data members. So we can put in a private simple computation, and then we have to have an import. Oops. Give it a name. SC1. We might need more than one. So we will need to import. Alright, doesn't know about anything yet, but take a look in here. You can see that we import JUnit.assert, and then a whole bunch of annotation interfaces. So let's import lab4 p1 dot, there it is, simple computations, and let's see, that fixed our error. Oh, spelling. There we go. Alright, so now we have our object that we want to test. So remember, the class we're testing is simple computations, and we want to create an instance of this. But notice that if you try to create an instance here, it'll fail. If you try to say SC1 is equal to new simple computations, it will fail because this, it turns out, is a static method which cannot access instance data members. So the fix for that is not to change this from static to something else, because you're not supposed to. JUnit requires those setup methods to be static. Okay, so we have to change these data members to be static, unfortunately. And then okay, so then it works, but we have to define the numbers that we have to put in here. So let's just use 1.0 and 0.4. Those are just the values that, it's two sample values that should work, and we have to make them float. And there. So I hope that's okay. And so once you're done with using this SC1 object, which is a simple computations object. You can get rid of it when you're done with all your tests, and one way to do that, even though it's not totally necessary, is to say SC1 is equal to null. Okay, so it's a good idea to do it because they are static after all, and so if there are other objects of this type, then that is other objects of this test type, they will all have the same thing, and that might be a problem, but chances are it won't. Okay, so far all we've done is we've created a new simple computations object with two parameters for the constructor, a in and b in, which are used to initialize a and b. So we're putting 1 and 4 in, just like we did in the main. And let's see what happens in the main. Actually, we didn't really run that, did we? So let's run this. Save that, doesn't matter. Okay, and I hope you can see this output. We set up a simple computations object to have a equals 1 and b equals 0.4. The subtraction gives us 1 minus 4, which is 0.6, and the division gives us 1 divided by 0.4, which is 2.5. Okay, pretty straightforward. So we can see in a main program that we just have to go to public static void main. That's where everything runs. Here it's not really obvious where main is. It turns out main is in our runner, test runner object. That's sort of hidden from us. We don't have access to it. So we don't have a main when we set up our tests. We just set up our objects and then we start using them. Okay. So we can leave setup, for example, empty for now and tear down as well. Let's do our simple computations constructor. I guess we don't have to do that yet, or let's skip that. So one way to make a test fail, and this is not what you want to do, is just to comment out the fail or just take it out completely. And let's try see what happens when you do that. Go back to the package explorer, and just to see, you don't want to do that when you write tests. You want to make sure you actually have some code in each test, and you will see that one of our tests passed, it's green. The others have an X through them, meaning they failed. So you can see some statistics. We had 0 errors, 3 failures. So not doing the best right now, but we'll get them all working. Well, one way to get them all working would be to comment everything, all the fails out, but of course we don't want to do that. So let's do the test compute first. So we will see what our predicted result would be. Let's say we choose a float temporary is equal to 1.0 minus 0.4. That should be 0.6, and then we will, float. Let's just say we can figure it out in our heads. 0.6f. That's good. And then we will call sc1 dot compute and save that in a float result. And here's where we use our assert method. So now we know what the answer should be. It's a 0.6, and then we call compute. It should return a 0.6, and we should check that. So we say assert equals, and the standard is to put the expected result, which is temp, and then the computed result, which is result. Okay, so at this point we get an error message saying it's undefined, and so let's go take a look at the documentation. Which method should we use? We should use an assertEquals that takes two floats but we have the closest one that we have is the one that takes two doubles, but it's been deprecated, which means it's no longer suggested that we use, and instead we have to use this one, which takes three doubles, the expected value, the actual value, and then a tolerance or delta. That is the difference between these two. You can't always be exactly perfectly right. You might have some slop, and so we say that, well, if it's close to enough to 0 by this much, that's good enough. Okay, so oops. Okay. So now that I spelled it right, I get this thing saying, well, it should be, you should not use that value of assert, you should use this one. Oops. And I'll try it. I'll try to say that there's no slop, that is, the difference between them has to be exactly 0. Okay, so there's no tolerance at all. So let's see what happens. You save this, go to the package manager, and run as JUnit test, see what happens, and lo and behold, it actually worked. So even with 0 tolerance, I was able to compute out the result to be exactly what the expected result is. So now what I'm going to do is I'm going to change this. Go up to the top here, and some of you may have seen this, where if you change just one data member from 0.6 to 0.9, that's 0.9 going into B, and I'm going to compute 1 minus 0.9, which we might expect to be pretty straightforward, that it should be 1 minus 0.9 is 0.1. Let's save it, and notice our test passed, but if you run it now, surprise, our test no longer succeeds, and it tells us that it failed right there. And you might say, well, let's take a look at this. Why is it not passing now? All I did was change the number change that operation from 1 minus 0.6 to 1 minus 0.9, and I should get to 0.1. Well, it turns out there is a round off error in that computation, and so you have to give it some amount of leeway, some amount of tolerance, like 0.0001. You save that and run as a JUnit test, and this time it passes. Okay, so we'll take a look at why that worked next.